Hello, this is part 17 of our Building with Claude API series, and this is our series finale. This is the last video of this series, and we're going to talk about the Model Context Protocol, MCP for short. Now, MCP is what allows us to make use of tools that other people have built. We've already seen how we can create our own tool function calls to extend Claude's capability. And just like how we create our own tool functions, other service providers, say for example GitHub, could have its own list of tools. And maybe another service provider, maybe like Higgsfield or Figma, they could all have their own set of tools that they want to expose to LLM. So that's where this protocol called Model Context Protocol came about. It actually came about from Anthropic to set up the standardized way in which all these different service providers can create their tools in such a way that all the different LLMs could understand. So that's what we are going to be seeing in this video. Now, the Model Context Protocol is essentially just a communication layer. And most of the time, this communication layer is just basically for your app to get the tools, prompts, or resources that you would need from some sort of a third-party service. All right. So let's take this example. If you don't have MCP and you're creating all the tool function calls, you would have to maintain that code in your app's code base, right? And using this first set of tools, you can talk with some sort of a service. And maybe this second set of tools, you could talk with another service provider. The thing though is, another app, maybe an app that you create or an app that someone else creates, they also would want to use the same service, right? It could be something like GitHub that a lot of people use. And this could be something like Figma, right? Now, this second app also now has to do that same redundant work of creating these tool functions so that it can access the same set of application services. It's a bit redundant, right? So that is where this concept of MCP comes in use. Instead of implementing all the tool functions over here, we only have a pointer, essentially this MCP client, which acts as a pointer to an MCP server, okay? And this MCP server then in turn contains all the tools that a particular app or service provide. So this separation of concern of having the tools handled by a dedicated MCP server is essentially the value proposition, okay? Now, because this MCP server is like the standalone service, another app which wants to use the same app or service could just create an MCP client which points to this MCP server, which would thereby have all the tools which this app needs. So this prevents each app from having to implement the same tools for talking with the same services. And another beautiful thing about this is the app and service themselves most of the time would have this official MCP server where they expose all the different tools and resources that they want. So the app or service, let's say for example GitHub, has total control over the tools and resources that it wants to expose to potential apps that wants to build with it. So there are a lot of advantages to having this MCP server client design rather than just hard coding, some sort of a tool implementation directly in your app. Now, the relationship between this MCP client and the MCP server is important. The MCP client is what we will have in the application layer, right? So that essentially is going to point to the MCP server, and there will be this connection between the MCP client and server to send messages back and forth, okay? And the logistics between this MCP client and server is handled by a transport agnostic mechanism. You could either use STDIO or HTTP. We'll see both examples very soon. So let's see a typical flow when we make use of our MCP client and server. We know that an app would have like a front end and like a back end, right? So let's call the front end as the app client and the back end as the server. Now, from the front end, let's imagine that the app wants to know what are the public repos that she has, okay? Now, this is the question. This is the prompt that is coming to our application, right? Now, since we have the MCP client available in the app server, what we will do is, even before we send this prompt all over to Claude, we would first of all need to get the list of tools that we would need to send to Claude, right? Basically the tool schemas, if you remember from the tools session that we had before. So all the tool schemas need to be sent to Claude so that Claude can use its intelligence and determine which tool it wants to use, and it can ask us to run those tools at our end. That's the first step, right? It doesn't matter what query or prompt comes in from the user. We need to get the list of all the tools from the MCP server to send to Claude. So that's basically the first step. There's this thing called the list tools request that we send to the MCP server from our client. Now this is happening without any LLM's help. Okay, so it's just a direct client server relationship that we have here. So we send this request to the MCP server, and the MCP server will just return back the list of all the tools that it has, and we get them back over here in the app server. Now, since we have both the query and also the list of tools over here in the app server, we send both of them, the query and the tools, back to Claude. Now, Claude makes use of its intelligence and figures out what tool it wants to use, okay, in order to achieve this. Basically, in order to answer this question of what public repos do I have, Claude needs to make use of some sort of a GitHub tool, right? Because the public repos that particular user has, it's present in the GitHub service, right? Claude doesn't know about that, right? So what Claude does is, it says, I want to make use of a tool use. So it just sends that request back to the app server. So it comes back here, and now the app server, what it does, it runs the tools with the argument that came in, and that goes to the MCP server. See, it goes to the MCP server again, and the MCP server is the one which knows how to request to GitHub, because the tool call happens here in the MCP server. So it runs the tool request to GitHub, and GitHub sends back the response to the MCP server, which then sends the result back to the MCP client, which is in our app server. So we have the result from GitHub back with us. So we just send that result back to Claude. Claude now has the context of the tool result. It will use its intelligence to give us back a response. Okay, so that's basically the flow of instructions that happen when we make use of an MCP client and server. So if you think about it, this is not very different from doing things without an MCP client and server. So the app client asks, what public repos do I have? And the app server itself will have the tools, right? Because this app server itself is going to maintain all the tools for connecting with like third-party services like GitHub. So here, since we have the tools, we just like send the query, which is this, and the tools that we have directly to Claude, and Claude will then use its intelligence to ask us to run a particular tool, and we know how to run it because the tool function is in our app server, right? We just run the tool. Basically, we request something to GitHub, and GitHub returns us some sort of a result, and we give that result now to Claude, okay? And that will then give us a response back. So this is how it works without MCP client and server. We've already discussed about this in that previous session where we talked about tools. So here, the only difference is, instead of the app server itself holding all the tools, it's the MCP server which is holding all the tools. So that's essentially the flow of instructions when it comes to making use of MCP. So the next part of the video is going to be practical code. Okay, so we're going to first look at how we can set up a simple MCP client for GitHub to access some repo information from it, and then we will set up our own MCP server and client connection locally and run it in a simple app. Okay, so first let's look at the MCP client example with GitHub. All right, so we have a regular setup going on here. So we just create the Anthropic client, and one additional step that we would need to do is we need to have a GitHub token. Okay, this you can get from the GitHub website. You can just create a personal access token and you put it in your .env file, just as how we have put the Anthropic key and the Voyage API key. Here we put the GitHub token also in the .env file. Make sure you don't commit it when you publish to a public repo, and we then like hold it over here so that we can use it whenever we want to make use of GitHub. Okay, and then I'll show you the client call that we are doing here. So we are using the beta version of the client.messages.create. Okay, so because the MCPs are currently supported in this beta variant, so you need to use client.beta.messages.create, and there you also need to include what betas you're using. So this is the string that you need to pass. You can actually like refer to the Claude API documentation based on the time at which you're watching the video, but this is what enables the MCP connector. Okay, and so you need to mention this string, and till now we have been passing tools to the client, right? In addition to tools, we are now going to be passing MCP servers, right? So that's basically how we have access to them, right? So tools, let's start with that. So if you look at the tools list, essentially just this dictionary where you specify the type of tool. Here it is an MCP tool set, and you specify the name of the MCP server. So you give it the name GitHub here, and this name needs to match the name that you're giving to your MCP server. Okay, that's very important. That's how Claude will locate the server, just to make sure these two names match. Okay, so over here in the MCP servers list itself, so you can define multiple servers. In this case, we are defining this first server where the type of it is a URL. Now, this is a server that is hosted somewhere, online. Okay, and we are going to access it through this particular URL. And we mentioned that, and here is where we mentioned the authorization token. Remember the personal access token that we saw on the .env file? We even have it over here, right? So we mention it over here so that Claude can access the server on our behalf. Okay, so that's basically the structure of the MCP servers list and the structure of the tools list. Okay, cool. So we just pass both of that into the client call, and the prompt that we are sending is, what are my 3 public GitHub repos with recent activity. Okay, so Claude has no way of knowing about this information, right? But because we are passing this GitHub MCP server to it, if we run this code now, it would actually in fact be able to give us a relevant response. I'll just print out the text blocks alone to see the response that we get. And here you have it. So the last 3 GitHub repos that have activity in my GitHub is the Intro to AI Engineering with Claude API, then the Beginner's Intro to AI Engineering, and then Building with Claude API. So these are the 3 repos that I had been tinkering with. It has even mentioned the date it had some activity happen on it. So that's pretty cool. So this happened because of the MCP server. Just by means of connecting to this URL, right? As an MCP server, we have access to all these different tools that GitHub offers, and Claude's capabilities are extended. Claude becomes much more powerful because it has access to GitHub now. As a matter of fact, there is this handy tool called MCP Inspector. You can just install it on your terminal, and with it, you can actually inspect a particular MCP. So it launches as a web application, and here, we need to specify the URL of the MCP that we are interested in, and if it needs authentication, in this case it does, so we just need to provide that information. So here we need to provide that GitHub token as authentication, and then when we press connect, it will connect us to the MCP server of GitHub and give us this nice dashboard look. Okay, so you can see all the different tools that come with GitHub. So this is the list of tools basically, add comment to pending review, add issue comment, create branch, delete file, fork repository. Basically all the tools that come from GitHub is over here. If we didn't have an MCP server for GitHub, we would have had to write all these tools by ourselves in our application if we want to use GitHub services. But thankfully we have this MCP server for GitHub, which gives us all this for free, right? You have all these tools which you can then now use. Now along with tools, you also have this pre-engineered prompts that you could use, and also resources. We'll talk about it a bit later. So this is pretty useful. All right, so this is essentially the MCP client. It's simple as that. In order to use MCP servers with your code, all you need to do is just get the URL and create the MCP servers list along with the tools list. Make sure the names match over here, and then plug it into the API call. That's it. And then, Claude magically has this extra power at your disposal. All right, now let's look at how we can create our own MCP server and use an MCP client to connect it with our app. So here we have our MCP server defined. So this is how you set it up. Okay, it's a very simple MCP server that we have here. So this is making use of this thing called the fast MCP. Okay, so this is again like a module that comes from this MCP library. Using fast MCP, we can define tools, resources, and prompts. Okay, so these are the three things that usually come along in an MCP server. A tool is something that would get a particular result for Claude. Okay, so anytime, let's say for example, it wants to get the weather, if we give this tool schema to Claude, it will ask us to run this tool for it. Okay, so it's basically what we have seen before. Now, just by including this particular decorator on this method, automatically a tool schema is created and with the description and everything that we would need. Okay, and then we also have these things called resources. Okay, so the resources are primarily for the application. So most of the time you wouldn't be sending a resource to Claude. Okay, so it's just to, like, for example, if you want to know the version of this particular MCP server service, you could maybe get this config. Okay, so this, again, you can just ask the MCP client to give you this config resource and use it in your application. So that's where this comes in handy. So the resources are just for your applications for most of the time. And then you have these prompts. Okay, so this is another element that you could get from an MCP server. Why would you ask for a prompt from an MCP server when you can yourself write the prompts? So this ties into that prompt evaluation and prompt engineering topic that we had discussed before. Creating a well-defined, reliable, robust prompt takes time, right? You evaluate it, run it through all these different AI evaluators, and then you craft that prompt. Now, you can create those well-crafted, engineered prompts and keep it in your MCP server so that the applications don't have to go through the process of like building that prompt themselves. They can just ask this MCP server, and on that prompt they could, obviously add the specificities that they would want to have. So for example, here we have a prompt that will like summarize any topic with 3 sentences. Okay, so please give me a concise 3-sentence summary of like a given topic. So this again is like a very simple rudimentary example, but in real world scenario, you would have a well engineered prompt here with these parameters that you can pass into it to add specificity for the prompt. So that's what this is. Okay, so these are the 3 usual things that come in an MCP server. Now, we already slightly looked at it when we ran the MCP inspector, the web application for the GitHub MCP server. So we will do that same for our local MCP server very soon. So now let's see how we could use this MCP server in our application. So in this video, we're going to see 2 ways in which we can connect to this MCP server. One is using the standard IO and the other is using the web route using HTTP. Now, for connecting our MCP client to this MCP server through the standard IO, all we need to do is run this particular Python application as a separate subprocess. Okay, and when it is running, you can actually talk to it by just standard input output and get the different tools, get the different resources and all the different prompts it has. And the other way would be to launch this as a server running on your HTTP and then get information from it. Either way, you need to somehow run this server, this MCP server, either as a subprocess or on the web as a web server. Let's first look at the stdio route. Here we have a client application, and contrary to all the other examples, it's not a Jupyter notebook. Okay, it's just a simple Python file. Here we are using the async methodology in Python. So you could explore all of this in detail, on your own using AI assistance. But the main idea here is when we run this code, like we will be able to like show tool schemas. So this is what will give us the schema of the server tools. Okay, so here we have a tool, right? So get weather, and we define this get weather as a tool. So when we come here and run this command, we'll be able to get a schema. So let's run that first and see the tool schema that we receive from the server. Okay, and then we'll look at how we are connecting to it. Okay, so we'll run this now. We can see over here that we have this input schema that comes along for this particular tool, get weather. So the input schema basically just takes in a string, right? The city name. So you can see that defined over here. So you see the properties, it takes in a city, which is basically a string, and it's a required property that it takes in. And you got this for free. This input schema, you got it for free because of this decorator that we added in the server. So let's next look at a weather request. Okay, so now we're going to send a weather request to Claude and we are going to get its response back. So let's run this out. And here you see that when we ran it with just this call, run weather request, you can see that Claude requested get weather. Okay, and we are asking the weather for the city of Tokyo. Okay, and this is going to call the MCP server because the get weather method is over here. And we're just going to return 20 degrees Celsius no matter what city comes in. You can obviously connect it to a real weather service provider to get the actual response. But the idea here is this tool calling happened from Claude. So here the Claude says the weather in Tokyo is currently sunny with a temperature of 22 degrees Celsius, approximately 72 degree Fahrenheit. So it was able to give us this response back because of the tool use that went into it. Okay, let's now dive a bit deeper to understand how it did this. Okay, and this will just give us a really good understanding of how we are connecting to the server to access this tool. Now let's go inside this method, and here you see something interesting is happening. So we are making use of two context managers. So the first context manager is called Stdio client. Okay, so this is something that we are importing from the MCP client. Okay, so the Stdio client. So what this is going to do, it's going to run this MCP server Python file as a subprocess. How will it do it? Because of this server params that it receives. Okay, where is it getting the server params? It's like a global variable right now. So if you look at this, so here you see we have this thing called the Stdio server parameters. It's another class that you're getting from this MCP.client module, and there we pass in the command that it needs to run to execute this particular MCP server as a subprocess. Okay, so here we say sys.executable. So this will basically give us the Python path in your machine, and Python, and to Python we're giving the argument MCP server.py. So since we are in this current directory, we just like runs it. It's like this. So instead of us typing this over here, we are doing it over here. Okay, so and this is what we are holding in this std server parameters. Okay, that MCP server is going to get launched as a subprocess. Standard output and input streams are here. Okay, you can read and write. Now the thing is, on this line, the read and write is going to be in like raw bytes. Okay, so what we do is inside this context manager, on the next line, we are making use of another class called client session. Again, this is something that we are getting from the MCP module. Now, because we have it, you plug the read and write streams into the client session, which then converts those bytes into like some JSON objects which we can work with. And we have the instance of the client session as session object, which we initialize. So, this is the handshake to connect with that MCP server that is running in your subprocess. So whenever you're using the standard IO and using the subprocess mechanism, you would have to do this every time that you want to talk with this server, because you need to actually run this and then only talk with it, right? And so that's something that we need to keep in mind. And then once we have the handshake set up, we can then use this session object to talk with the server, right? So we pass in the session object to this method called run with MCP. So it's basically a helper method that runs Claude client with this particular MCP client. Okay, so let's look at what's going on. So here what we are doing is we are giving a prompt saying what's the weather in Tokyo. Okay, so that's the prompt that we want to give it to Claude. So when we go here to this method, what we're doing is first of all we're getting all the tools that the particular session MCP client has. So this is exactly the point that we talked about over here. So the first step is to get all the tools that the MCP server has. So over here we get the list of all the tools that the MCP server has, and then we convert it into this particular JSON object over here. See this list of tools, and we are passing it in to the client.messages.create. So this is the Anthropic client, right? And we pass it into it. Now, if you observe the difference between this call and the other one, like the one that we used before, right? So the MCP client with the GitHub. So there we use the beta version of the client call, because over here we are directly feeding the MCP server itself into Claude, and Claude itself from its server is contacting the MCP server. GitHub's MCP server, right? So that's happening from Claude. Whereas over here in our local application, what we are doing is we are only passing the tool schema. See, this is the tool schema that we are passing in, and the tools themselves, we are not hosting it in our application. Rather, we are getting it from the MCP server, which is over here, right? So that's the difference. So here we get all the different tools from the MCP server back to us. So we got it back, and we pass in the query with the tools to Claude. So we pass in the tools over here, and we are passing in the query, which is this user message. What is the weather in Tokyo? So that was the message, right? So that is also created here as a list and passed into this. Perfect. Now what Claude is going to do is going to send us a response saying it wants to do a tool use. Okay, so it's a simple loop here that we have set up so that we address those tool use requests. Okay, so whenever there is this tool use request, we actually in fact do the tool use. See over here we are like calling the particular tool call that it wants with the input that it has given. So this again, we are doing it with the session object itself. It provides this helper call tool. And what's going to happen is it's going to like ask for this get weather tool to be called, which will happen here. And the result of that will be added to this tools result block. And we are appending it to the messages list. So this is something that we have already seen before. We have like manually run each of these things when we were discussing about tools in detail. So that's exactly what we're doing here. We are appending to the messages list the tool results. And that's what we saw here when we like ran it, right? When we ran the application, we were able to see the response from Claude. See the weather request that, see over here, it's doing. We got the response from Claude. The weather in Tokyo is currently sunny with a temperature of 22 degrees Celsius because of the tool use, because of all the things that we just now saw happening inside of this particular loop. So that's it. That's basically what's going on. Instead of having the tools directly in the app server, we are actually like, hosting it in this MCP server and asking it to do the tool calls for us. Just like how we get the tools, we can also get the other resources that we talked about, like the prompt and the the resource file. I'll just uncomment these lines, and here we see, just as before, anytime we want to do this server use, we create the sub process here, and then we create the actual session object, which is the bridge between the client and server. And then what we can do is we are like asking it to get the resource. Okay, so here if we go to this method, like we have a session object and saying this is the resource that we want. Okay, and if you look here, we had defined this is the URL for this particular resource, this dictionary object that we are returning back. That will be sent back to our application, and we can do whatever we want. Similarly, we can also get the prompt that we want. So here, like if you click on this, so you pass in the session object, right? So here we want this prompt called summarize, which we have defined again here, and it's taking in this particular input. Topic is climate change. So it's going to return back a prompt with the climate change added here in the string. So I'll say, please give me a concise 3-sentence summary of climate change. Okay, so let's look at that as well. And here we see from the server, we got the resource over here. And then we also have the prompt coming back. So here, please give me a concise 3-sentence summary of climate change. And we can decide however we want to use this. We can like, send this prompt into Claude to give us a result back, and we can even use this resource, however we seem best. This is what the MCP server allows us to do. As a final step, what we'll do is we will check out the same MCP server running as a web server rather than through this sub process. Okay, now to run this MCP server, we just need to like give this argument HTTP. Okay, so let's just use this and run it in our terminal. And when we do that, see the server is now running in this local host. So the server is running over here in the local host 8000 port /MCP. It's giving us something, okay, but the server is running. And to test this out, we can use that MCP inspector that we talked about earlier. So let me open up a new terminal. And on it, let's use the MCP inspector and give the path to our MCP server. And there you have it. Just by means of giving the URL to our MCP server and ensuring that the transport type is streamable HTTP, because that's what we have defined here in our MCP server when we like launch it as a HTTP server. Now we can check out all the different tools that it offers. See this get weather tool that we had defined in our MCP server, right? Get weather tool is like showing up in our dashboard, and you can see the actual tool schema over here. And now the cool thing is you can actually give it like the input argument. Here we can like give the input of Chennai and run the tool, and you see the weather in Chennai is sunny and 22 degrees Celsius. So this is like the output. Weather in the city is sunny and 22 degrees Celsius. This is basically coming back to us from the dashboard, right? It's actually using the tool and showing that it is actually working. So this MCP inspector is like a useful, dashboard tool that helps us to check our MCP server before actually using it in production. And then, you can also see the different prompts that we have. We have the summarize prompt, right? If you click on it, like, you can give it some kind of a topic. Let's give the topic of AI and get prompt. And you can see the prompt that we get is, please give me a concise sentence summary of AI. Like whatever topic you give, that will be added here. So that's also working. And then finally, we see the resources. So here, like if you click on list resources, you can see get config, and you can see the that version that we had specified, right? Version 1, so which we saw here, theme dark, language English. So this particular resource is also coming back. So that's pretty cool. And since the server is now running, like you can have your client app directly connect to it without having to use a sub process. Over here, instead of launching the sub process, here we are connecting to the streamable HTTP client. Okay, this again is an object that we are getting from the MCP module, and using that, we just need to do it one time here. You need the server URL, obviously. This is the localhost 8000 port MCP. That's the URL which we are connecting to. This is like the MCP server, right? And that's it. Once you have the URL, using the streamable HTTP client, which will stream in the read and write streams as bytes from it, and then you have your client session object created over here, which will convert them into like JSON objects, and you have the object which we are initializing to set up the handshake, and that's it. Like then on, you can just use that session object for like showing your schemas, running with MCP, getting your resources and prompts and everything. I'll just like run this script to show you like all the results that we get out of it. And here you can see from the HTTP server, getting all the similar responses back, right? Like we are getting the input schema from the server. Claude was able to make use of the tool use and give us a response saying the weather in Tokyo is currently sunny. And then we can also see how it got the resource config back, and then we can see the prompt also coming back. Please give me a concise 3-sentence summary of climate change. That's basically it, right? So this is how we could make use of the MCP client and server. That's the idea, right? Like, when it comes to the implementation details, yes, like here we are making use of async. The reason we are using async is because to get the information back and forth between the MCP client and the server, using async is much more conducive. But the main thing that I want to share here is the idea, flow of instructions that is happening. Basically, all the tools, instead of being in the app server, is moved to the MCP servers. Yeah, so that's basically what the model context protocol is. Hope this video was useful, and hope this entire series itself was actually useful. Thanks for following along, and all the very best.